Including yourself and me.
Yeah.
And I believe that there are some who are using 2 devices, so they are registered as participants as well. As soon as I get the green light, then we shall begin with the webinar. Yeah.
Okay.
If that's okay with you.
Yep.
All right.
I prefer to start straight away because we have only 1 hour, right?
Yes. Don't worry, I shall not take the limelight from you. All right. The clock indicates it's 3 o'clock. Okay, we have more or less 77 participants, so I think we can start now.
Yep.
Hopefully everyone can hear me clearly. Okay, hello and welcome everyone. Thank you for joining us for today's international webinar series, Research Trend in Computing Science, which is jointly organized by Faculty of Computer and Mathematical Sciences, Universiti Teknologi Mara, Cawangan Melaka, Malaysia, and Fakultas Ilmu Komputer, Mercu Buana University, Indonesia. So this is going to be a 1-hour webinar, and this is the first of, inshallah, 10 webinars that we have in the pipeline. So my name is Azlan Abdul Aziz, your moderator for today's webinar, and I'm from UiTM. I would like to wish and extend my thank you for everybody for taking your time out and for being here today in this webinar session. All right, today we are presenting data science in oil and gas industry, and presented by all the way from London, Dr. Shurya Amiruddin, data scientist from Shell International Limited. All right, just a little housekeeping before we get started. If you have any questions during the presentation, you can please type them into the question box in your WebEx control panel in the chat area. Inshallah, I'll bring them up at the end of the presentation. And at the end of the presentation, we'll be running a live Q&A session. So during the Q&A, you can also unmute your mic to raise your questions, and I can also raise the questions that were texted in the chat area. All right. Okay, let me provide the audience with a brief description on our esteemed speaker. Dr. Shurya is a data scientist who works at Shell in the digitalization department. To be specific, she's working for the computer vision team in a project to digitalize graphical logs of oil wells. She was born and raised in Malaysia, but now lives in Coventry, UK. She has a PhD in computer science, specializing in human-computer interaction. And she has been in data analytics, machine learning, and deep learning field for over 3 years. And she has over 6 years of experience in software development field with solid programming skills, outstanding data wrangling and visualization capabilities, as well as excellent communication qualities that allow her to communicate her findings and suggest solutions to the more often than not complex problems. In her spare time, she likes traveling and reading. She also spends a decent amount of time dedicated to her own self-improvement and development. Wow, very beautiful. We should follow or emulate this as well. because I believe there is lifelong learning, or there's no stopping in learning, right?
Yeah.
So she always keep herself updated with the latest artificial intelligence advancement. As we all know, around the globe, AI is constantly changing and evolving and changing the landscape, either in education and in the other industries as well.
Mhm.
Right. I would not like to, let me just rephrase that again. I would not steal the limelight from the speaker today. So now, without further ado, we will turn the time over and I'll pass the floor to Dr. Shuria and welcome her to deliver her talk. Please, Doctor.
Okay, thank you very much, moderator. So I'm Shuria. So today I'm going to talk about data science in oil and gas industry. So we start straight away. So my contents of today's talks is basically I will discuss about a little bit about the nature of business in oil and gas industry, and then we will look into predictive maintenance and seismic diagnostic. Okay, so yeah, before we go to directly machine learning or deep learning applications in predictive maintenance and seismic diagnostic. So let's see what is the nature of business in oil and gas industry. Okay, so what oil and gas do? Basically, their business, of course, to sell oil and gas. Okay, um, because they're oil and gas company. Okay, but other than that, they also generate income from rented out their offshore equipments, and then there are many small oil and gas company that don't have equipments, and when they won the bid to get blocks area for oil and gas exploration, so they will rent all these equipments from big company. Okay, so this is how the oil and gas company generate income. Okay, so oil and gas company also do trading with stock market investment. So there is a specific department that handle this. Um, so this is actually not directly related to oil and gas, but they try to diversify their income generation. Okay, and then oil and gas company also explore renewable energy like solar energy and wind energy. So this is a future direction to have clean energy and reduce the carbon dioxide emissions. So this is basically what I can say. Uh, the things that Shell do. I'm not sure the other oil and gas company, but I believe they also explore this kind of new renewable energy. Okay, so here this is how we utilize the machine learning, deep learning, data science in predictive maintenance. Okay, so basically predictive. Oh, I'm sorry. So I'm mute. Sorry. Okay. Uh, okay. Let's start with predictive maintenance. Okay. How we use data science for predictive maintenance. Okay. So basically, you know that oil and gas company rented out their equipments, so they have a lot of offshore equipments. So how they can maintain these equipments? So they use data science to maintain all these equipments. So here you can see the example of equipments, offshore equipments like compressor, generator, drilling equipments. Even for compressor, we have a different kind compressor, different type of compressor. Okay, like gas compressor, air compressor, and things like this. And then actually, my first experience in Shell actually to handle a big data set uh, with 400 features of a compressor. So this is actually 2 years of data, which record data for every 5 minutes. So it is a time series data set. So uh, the 400 features here is actually the sensors inside the compressor. Okay. So in one compressor, because this compressor is very big, so a lot of sensors inside this compressor. Okay. So what we did, normally we need to predict the sign of failure of this compressor. Okay. So before it fail completely, so we need to predict when it start showing sign for that failure. Okay. So once we got these signs, so we need to do intervention before it's happened. Okay. For this purpose, we develop a model, machine learning model. At that time, we use classical machine learning model like one class SVM, isolation forest, PCA, reconstruction error. Okay, this model we developed from the time series data set, and then we try to predict just hours, few hours before the failure happened. Okay, so that's why we use the SVM, isolation forest, and PCA reconstruction error. This is just to predict the time when it will happen. Okay, but to predict which sensors that cause the problem, we use a different approach, which is Z-score. Okay, so actually Z-score give idea how um, the data point. Okay, Z-score is actually it actually to see the distance between data point from the mean. Okay. So basically, if the data point is far enough from the mean, so we can say that there is something wrong with that particular features. Okay, for that particular sensors. Okay. So normally we list top 10 of sensors that have high possibility that cause the problem inside the sensors, inside the compressor. Okay, so once we got this top 10 list of sensors that we assume, okay, will cause the problems, we send out this information to engineers. So these engineers will investigate and fix the problems. Okay, before the compressor down. So because if the compressor down completely, it will take more than 1 week to up again. And then, yeah, it will affect the production, and then the 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 production, and then the money as well. Okay. So this is what I did last 2 years, I think. This is okay, this is actually just one compressor. So you can imagine in oil and gas company, you have a lot of equipments. So each of these equipments uh, need for a model. It's, their own models to predict when it will happen. So yeah, there is a team, specific team to handle this. We call it the team, a predictive maintenance team, which they handle a different kind of offshore equipments, okay, to maintain the equipments. And then let's see. So for I can suggest here the research area would be useful to explore. Okay, maybe you can look for a industry which heavily rely on machines, and then for example a factory, and then try to get the data set for analysis and then propose the solutions. So for me, this predictive maintenance is a 1D data, numerical data set, which you need to have a very strong maths and statistic background. You need to know the threshold value. You need to define the threshold value when it will happen. And then it's basically, for me, it's I can say it's hard for me. Okay, because you need to have a very strong background in maths and statistics. Okay, and then once you got the analysis, you need to create a story and try to make sense from it, and then try to um, tell people, okay, this is what happened. Okay, so basically we try to convince them, okay, from the statistic that we got from the data sets, okay, the pattern from there, and then the model we develop for that, okay. We not rely on only one model, so we have different kind of classical machine learning model. But I'm not sure. Maybe currently they start looking for deep learning. So but yeah, deep learning is more easier as compared to a classical machine learning models. Okay. Okay. Now move to seismic diagnostic. Okay. So this one okay, we will start with the oil auction. Okay, oil auctions. So basically government normally have few blocks areas for oil and gas explorations. So the oil and gas company needs to bid the block area they want. Okay, they want to explore uh, and drill to get the gas and oil. Okay, so the oil and gas company, when they won the bid, so they will get the license to do the drilling for oil and gas. Okay, but before they go for the auction, what should they do? Okay, this is the decision that they need to make. Okay, so the decision here is from the investigation, uh, from the data analysis that we will do. Okay, so need to estimate the value of oil and gas for that particular block area. So before they enter the auction, they need to know what is the value of oil and gas down the earth there. Okay, so and then and then the oil and gas company need to do the analysis for this. Okay, so what is seismic data? Okay, so for oil and gas exploration, basically you will start with a seismic wave that give the idea where oil and gas can be found. You can see here there is a ship. This is a survey ships. It will put here the wave, try to get the wave. This is, we call it a seismic wave. And then they will get the information from this wave. Okay. So they also try to identify type of rocks and the pattern that leads to oil and gas to be found. And then only they can estimate the value of oil and gas. Okay. So this is just a general idea that I shared with you, because I'm not really geologist that know everything's about the rocks, but basically I know in general what is the yeah, the lithology logs. Okay, because in lithology logs you have different kind of rocks. So basically, who who um who have the geology, I mean geologists normally have uh, knowledge on this, okay, type of rocks, things like that. Okay. So seismic data, where you can get the seismic data. So basically, you buy from other company because other companies sometimes have this kind of informations, or get it from a government because when government say there is an auction for oil and gas block area, so government have this kind of information, seismic data. So they will provide to all the bidder. So so the bidder need to do their own works, okay, to estimate the oil and gas down the earth, okay. And then okay, and then this is what we can see from seismic diagnostic, okay. So seismic data, you can see actually the wave. Okay, from this wave, you need to infer what you can get from there. So what I shared here is just graphical logs. Basically, you can see in any oil and gas company, they have this kind of logs. So my experience actually, I need to digitalize these graphical logs. So because I deal with legacy logs is a logs from 100 years ago. Okay, 100 years ago. They draw by hand, they write handwriting. Okay, but we need this kind of information. Okay, so that's why we try to extract this information from these legacy logs. This is very challenging task because it's the legacy log what it looks like. It just because it is on paper, and then you save it in a form of PDF file, where sometimes the image is not clear enough, and then a lot of noise, and then the line skewed, and then yeah, a lot of problems with this kind of graphical logs. So normally we don't have problems with modern logs. Modern logs is like uh, I shared here two images here. These are modern logs. I can say these are modern logs, but for legacy log, I try to find one by Google it, but I yeah, I I can't find it. Okay, but basically this is the logs we work on. Okay, so we try to extract the text over here. You can see we extract this text. We use optical character recognition (OCR), and then this is part of the NLP, natural language processing. So you need to train a model and then get uh, the information from the logs. Okay, but it's nice because it can detect all these words inside this. For a modern log, I can say it's almost 99%. It can extract the information from this image. But for legacy log, we have problems with the character sometimes not recognized. So, but basically it's improving. Okay, but yeah, it's quite challenging dealing with legacy logs. Okay, so I did a lot on image processing, like denoising and deskewing. Um, so because uh, the legacy logs is a lot of noise. Okay, salt and pepper noise, and then the line not clear, and then yeah, a lot of things. So we explore different kind of deep learning models which can denoise um, denoise the legacy logs. Okay, and then but this queuing is still in progress. It's, it took it took I think almost 8 months already, but still not working for this queuing. Yeah, but still improving. We still improve this queuing process. Okay, and then this is another task. This is my experience where we need to extract information from the lithology columns. You can see here lithology columns. These are the type of rocks. You can see here clay stone, yeah, hardpan mudstone, sandstone, all of this. Okay, shale. So if you can imagine the logs, the graphical logs of oil and gas, yeah, company, the log is too long. Okay, it's more than 2 or 3 meters. So what we can do, we split the images into small parts, and then from there we process one by one. Okay, because it's not possible to process the log, that very big log. Yeah, but all of this log they transform into PDF files. Okay, a lot of yeah, pages for this kind of logs. Okay, this is just part of it. Okay, I got it from Google. So currently I work on this box detection. I need to detect box over here. So from the legend. Okay, this is box detection is part of the legend detection. So we need to detect the box, and then we detect the legend. So so you can see the legend, and then after we detect this, we produce we crop. Okay, inside the symbol inside this box, we crop it, and then we try to match this uh, to the area which have the same symbols. Okay, so in this case, we try to look this symbol inside this lithology columns. Okay, so how to do this? We use multi-template matching, MTM. So basically, it's already developed maybe by a researcher. So we just download the from GitHub the code, and then we try to apply it on our logs, and then yeah, it's quite challenging these times, but I really like it. As compared to predictive maintenance, I like the computer vision parts here, because we deal with a lot of images, and then yeah, we use Python for this. Okay, so and then the task here involved with train and test the model. Okay, it's not only one model. We have a lot of models. Okay, for box detection itself, we have 2 or 3 models which we need to compare. It's kind of research. Okay, research. So we do a lot of models. Okay, we compare. We develop a matrix for that, so that which models that perform better. Okay, so here we need to identify the to the true positive, true negative, false positive, false negative, and then compute the accuracy, recall, precision, F1 score. Okay, this is for box detection only. Okay, then only we decide which model that we want to use. Okay, and then for template matching, So once we get this one, when we crop out the symbol from the box detection over here, so we do the template matching. Okay. So we call it MTM, multi-template matching. Okay. We try to match this template. Okay, this template means the legend here, the image that we just crop out from the box. We call it template. So we take this template over here and try to match it inside these lithology columns. Okay. Okay, this is another metric that we need to develop. Okay, because we want to see how it's perform. Okay. So for my project, uh, there are 3 peoples on this computer vision part. We have 1 intern there, and then to work with this, and then because previous last 2 years we already developed the model for detecting this symbols, but it's just that the models is not so good, and then we develop a new one. We call it nice. Okay. And then okay, for this seismic diagnostic, what I can suggest you to use this seismic diagnostic to study the earthquake using a seismic data set. Okay, this one I think you can get the data set from the government if yeah, because normally I think the government have a way to give alert to people when the earthquake will happen. Okay, so there is a measurement for that. So I believe that government has that kind of information, that kind of data set. Maybe you can ask for it, and then you can try explore this kind of data set. So this is uh, this is what I can suggest you to do research. Okay, on seismic data set. Okay, and then other research areas you can see. You can also explore the customer analytics. Okay, so this is actually to improve customer experience, building customer loyalty. This is I'm not I'm not directly involved with the customer analytics, but I know in Shell they have this department that handle this kind of information customer analytics. Okay, uh, there there are specific peoples that doing this kind of things, and then they develop a model for that. Okay, so for trading, this is actually time series data set. So basically, they do the investment on stock markets, and then for this, they need stock market prediction model. Okay, I believe that there is a team for this kind of model development for trading in Shell. Okay, for this is for renewable energy, but for renewable energy, I'm not really sure, but there is a forecasting of the solar energy. So you can see this as well if you want to focus on solar energy. So this is specific area that you can explore, and then you can develop a model for this. Okay, these are all kind of data science that you can apply. The area that you can apply uh, to apply using data science. Okay, you develop models and then do the research on this area. Okay, conclusion over here. So actually, you can apply data science in various business industries. So you can see aerospace, transport, computer, telecommunication, agriculture, construction, education. yeah, healthcare, entertainment, a lot of areas, okay, business areas that you can apply this data science. Okay, so you can try look for a company and then negotiate to get the data set for analysis. Okay, and then you also can explore the nature of business of a company and then propose a new approach to improve the business process. Okay, uh, I think for I can share my experience from this. Let's see. I'm happy to receive any Q&A, questions and answer session. So it's easy for me to discuss with you. Maybe you want to get some ideas on how to do the research, and then this kind of things that I did in a company. But it's not for academician. I know that they need to produce a paper and then send to a journal and things like that. But in industry, it's more to production. So basically, we use Python to develop all the codes, the production codes, and then I can say the if you have background in computer science, is quite easy for you because it's kind of multidiscipline fields which you need to develop a code for this kind of things, and as well as you need to know the data science, and then you need to know the machine learning models, deep learning models, all other approach. Okay, so please bear in mind because sorry, I think I read something on my screen. Someone asked me about annotating. What is that? Can you explain that, please? Okay, let me continue. Any question, just ask me. New rule to annotate the shared content. Okay. Okay, let me approve this. Okay. Oh, okay. So I can annotate using this. Okay. So this kind of task that I do in Shell. So we have a team to develop this kind of seismic diagnostics. So we deal a lot of graphical logs, and then basically it's work for one logs, but it's not work for other logs. So that kind of thing. So it's quite challenging. Okay. So currently I can say for this queuing, maybe it's work for 10% of the logs. We have 200 or 300 logs, graphical logs, but it's work only 10% of the logs. And then for legacy log, it's quite difficult. So still working on it. For example, you can see the left hand side here. You can see the image over here. Even the lithology columns here is not straight line. Okay, so when we try to detect, we actually this one. Okay, the line over here is not straight, so it's quite difficult to detect this because when we annotate when we predict the symbol, we predict in a form of bounding box. Okay, bounding box is a box yeah, box. Okay, and then yeah, it's just not fit with the line over here. It's not straight, but it's just nice over here in the modern lock. Okay, you can see it's straight line, and then it's easy. It's perform better. The model perform better if with the modern locks. Okay. So basically, we're still working on it. Keep improving the models, and then uh, a lot of try and error and research, and then we download Python code from the GitHub, and then try and error, and then do the metrics for that, because we need to compute uh, how this model perform, and then choose the right one. And then yeah, for me, if I compare between predictive maintenance and seismic diagnostic, because predictive maintenance deals with numerical data sets, but seismic diagnostic we deal with images. Okay, so I prefer to deal with images as compared to numerical data sets, because the numerical data set you really need to have a good understanding uh, in maths and statistics. Okay, but for image, it's quite straightforward as compared to yeah, predictive maintenance data sets. Okay, so any questions? Oh, okay. Uh, okay, there is the questions here. Commonly, what is the percentage of accuracy that will be accepted by industry? Uh, it depends on the locks. Okay, for modern locks, because I develop a box detection. Let's see how to move. Oh, sorry. Um, okay, for box detection over here, I can say for modern locks we can detect up to 99% accuracy, but for legacy locks, it's just 65%. Okay, correct, correctly correctly classified. But for modern locks is easier because yeah, the box is standardized, and then it's straight line. Okay, the vertical and horizontal line is straight, but for legacy lock we have a skewed line and things like that, so it's quite challenging in that case. That's why we try to implement the deskewing, but yeah, still struggling on that. Mhm. So any more questions? Maybe
Any
you
other
want to get
questions?
some idea. Yep.
Any other questions from the public, from the floor?
I got question. Can I
Right.
ask?
Yeah, go ahead. Go ahead.
All right. So, Dr. Surya, so as someone who I can say fully experienced in data scientist,
Mm-hmm.
so if you were given a chance to pursue
Mm-hmm.
another field, but still
Mm-hmm.
related to data scientist, which
Mm-hmm.
field do you think the best you will go to utilize your skill as a data scientist instead of oil and gas?
Yes, actually, I'm looking to move from oil and gas company to another company. So, but for I think a lot of companies need the experience on handling a numerical data set. Okay, numerical data set is like predictive maintenance. It's like customer satisfaction analytics, things like that. So because yeah, a lot of company ask for that. Nowadays, there is a company NHS. In Malaysia, we call it KKM. Oh, okay. Because they want to analyze the COVID-19 data sets. But yeah, but I know it's quite difficult for me. But I think my experience, I love to use computer vision skills that I have. But the option that I can see out there can be whether as a research fellow or in healthcare industry. Okay. Um, yeah, for computer vision, it's not many choices to move uh my career with. But yeah, I think if you can explore more on predictive maintenance or numerical data set, or we also call it a 1D data set, and then it's more useful to you.
Dr. Surya,
Mm.
on a lighter note, I think based on the information that you have given us just now,
Mm-hmm.
more likely in the not so distant future there will be an opening in the area that you're working on then. So there should be an opening for people who are interested to apply. Am I right?
Yeah. Yep.
If you're moving to a
Okay.
different area or a different industry at that.
Okay, but there is driverless car. That's kind of thing. I think we'll use this computer vision skill set. Yeah, but yeah, I'm not sure.
Yeah, that's
Sure.
another question, Dr. Surya.
Mm-hmm.
That's another question.
Hello. I can't hear Dr. Azlan. Is that because of my internet?
We can hear you very
Hello.
clearly, Dr. Shurya.
Hear me?
Maybe Dr.
Oh,
Shurya
okay.
can.
Dr.
Now I
Surya,
can
Dr.
hear you.
Surya, yeah, all right, okay.
Mm.
Okay, Dr. Surya, a question
Mm.
from Dr. Nur Hasima. Apart from analyzing images,
Mm.
is there any other kind of project or data that require data science analysis in
Mm-hmm.
oil and gas company?
Okay. This is I mean, analyze the images is just part of the mm, I mean, analysis that using data science. But actually, a lot of areas that use 1D data. I mean, numerical data. It's not image, because for images we call it 2D data set, but for uh, numerical data we call it 1D data set. Okay, we also have 3D data set, but it's really hard because yeah, 3D data set where you can see, yeah, from different areas. Okay, normally they try to use this 3D data set for analyzing any um, leaking in pipe, things like that. But I think I would suggest you to focus more on predictive maintenance or trading or customer analytics. Okay, this kind of 1D data set, uh, and then you can predict. Yeah, you can from here you can predict. For example, the predictive maintenance. Yeah, you can maintain the 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 equipments, for example. And then for customer analytics, here you can um, recommend. Okay, for example, if you go to Amazon, so you can see a recommendation of what kind of products. Okay, you can recommend. I mean, the Amazon recommend to you. Okay, that one is using the yeah, the data science. Okay, if you go to Facebook, is detect your face. That's also, yeah, deep learning models. They utilize the deep learning models. Okay, any more questions?
There's another rather your opinion on this, your take on this, Doctor, from
Mm-hmm.
Dr. Jamaluddin. Is there
Mm-hmm.
any roadmap for postdoc?
Postdoc?
Uh,
You mean postdoc in Shell?
I'm not so sure. I think we have to ask TS Dr. Jamaluddin to clarify this question. Is Dr. Jamaluddin? Can Dr. Jamaluddin please clarify the question?
Or maybe, yeah, a lot of postdoc actually did in UK universities, but you need to, yeah, you need to apply for that.
Hopefully that answered the question, Dr. Jamaluddin.
Mm-hmm. Mm-hmm.
All right, from Dr. Shafa, there's another question. How many images that will be used for a particular analysis? How many images that will be used for a particular
Yeah,
analysis? Yeah.
currently we use around 100 images to train, but we knew that it's not enough, but it's that our capacity at this time. So we use whatever we have, and then we train these 100 images, and then yeah, to get a model for that. If you ever heard about DETR, DETR is from Facebook. This is deep learning model. Um, maybe I can write here. You can, yeah, you can explore DETR. Oh, sorry. Okay, DETR. This is detection transformer from Facebook. Okay. The good thing about the ETR is you can train a very few images, but it can the performance is better as compared to other models. Yeah, yeah. I think I answered that question. Only 100 images. Yeah.
All right, all right. Thank you so much.
Mm.
Any other questions from the audience? Okay, a question from Puan Nur Fadila. What does DETR stands for?
The ETR stand for detection transformer from
Detection
Facebook.
transfer. Oh,
Yeah,
okay.
detection transformer from Facebook. This is a new models released in 2020.
Oh, quite recently
May
then.
2020. It's not even 1 year. 1 year yet. So yeah, it's really new. But we also we already explored this one. So basically, in yeah, even this is industrial research. So even we are not from academician, academic area, we still uh, we still do a research based on the research paper, the current research paper, and then if you ever heard about the internet link paperandcodes.com, papersandcode.com. So there you have a research paper as well as the code they share in GitHub. So basically, we use this kind of things. We read the papers and then download the code from the GitHub, and then we try to apply on our using our images. Things like that. It's nice too. Uh yeah, I'm not academicians. Yeah, yeah, still. I have a part-time, yeah, associate lecturer in one of the university, but not really. Yeah.
All right, another question. It's more. I think this is more of a future collaboration, if possible, from Puan Nur Fadila. Is there any chances for us to have a research collaboration with Shell?
Currently, I'm not sure because Shell still in the process of restructuring, which I mean the pandemic actually hurt badly Shell. So they're restructuring and then reduce the people in Shell, and then yeah, still it's still going on. So I don't think they have a collaboration with yeah.
With universities, you mean?
Mhm.
I
Yeah,
see.
universities. Yeah.
All
Mhm.
right. Okay, it's a very
Maybe
good
next
thing.
year, yes. Maybe next year, but
Hopefully,
not this
inshallah.
year. Not
Yeah,
this year.
hopefully,
Yeah.
inshallah. Uh, it's a good thing that the there is more time for us to have a question and answer session because I can see that questions keep coming and popping up. All right.
Yeah.
There's another question from Puan Zurah Abu.
Mm-hmm.
It seems that like a lot of statistics application are being used. So from your experience, can you suggest us research related to statistics in oil and gas industry?
Statistic. You mean the data visualizations?
I think so. If you need further clarification, we can just simply ask Puan Zura Abu to unmute her mic and pop the question. Oh yeah,
Mm-hmm.
yeah, she said so.
Yes. I think data visualization is one of the area that you can focus at. In Shell, they use Power BI, they use Altair, they use Dash in Python. But I think going forward in the future, we will focus on Dash. Okay, Dash and Plotly for data visualizations. So last few days, I think a couple of days ago, we have a talk from Plotly people from Houston. So I think Shell quite interested to use Dash and Plotly, and then yeah, you can you can explore that one, Dash and Plotly. Apart from that, you can see Figma. Figma, maybe I can type here Figma. This is a new one, Figma. Okay. This is for data visualization, Figma, Power BI, Altair, actually Python. You can install the package, Python packages Altair. Yep. Any more questions?
Any other questions from the floor? While waiting for other questions from the participants, I just would like to uh, highlight there is the attendance link for today's session in the chat area. So kindly proceed to fill up the attendance link for today's.
Mm-hmm. Okay, actually, if you have any questions on the recently research area that we look into, you can email me, shurya@gmail.com. That's my first name at gmail.com. It's easy Gmail account. Gmail, account name, shurya@gmail.com. And then you can ask any questions. And
Yeah,
then, I will try to guide you whatever research that you want to do. Or maybe
all
I
right.
can share, my
Go ahead,
experience.
Dr. Shreya.
Yeah, I can share uh, whatever new things that
Information.
we have in our project,
That
and
would
then
be
which
very good.
you can, yeah.
Yeah, that would be very good. Okay.
Mhm.
So any other questions? Because we are nearing the end of our session. It's almost
Mhm.
4. I believe it's almost 9 in London.
Yes,
Okay.
I have class actually at night.
Oh, really? Oh, okay.
Yeah.
All right. That is Dr. Shurya's Gmail account. So if
Mhm.
any of the participant wishes to communicate further with Dr. Shurya, you can reach her through her Gmail account, shurya@gmail.com.
Mhm.
So I think that's a wrap for today. Before, let me
Yeah.
just check this first.
You want to take picture?
Definitely. So before we proceed to taking the photograph, is there
Mhm.
anything else that you wanted to cover before our wrap up, Dr. Shurya?
Mm, I think that's all from me, and then all the best to you for your research. I know academician is really into research. And then this kind of area is new areas, which I think that's for future going forwards.
All right.
Yeah. Okay, all the best to you.
All right. Thank you. So can we have Dr. Surya to switch off the sharing of content so that we can have the layout for the photograph?
Okay, stop sharing.
Yeah, thank you very much. All right. So if everybody, the participants, if you can kindly switch on your webcam for a short while so that we can have a short photography session.
Let me.
All right. Okay. Ready?
True.
One, two, smile. Don't forget to smile, people. One, two, three. All right. Thank you very much. Okay. Thank you, Dr. Surya, for this sharing session. We will go ahead and proceed to the next part of the webinar, which is the end actually of the webinar. Okay. It's a great thing that we have the opportunity to get some insights in the oil and gas industry relating to data science. All right. Thank you, everyone. We appreciate you being here. And just do not forget to be on the lookout for our next webinar. The recording of this webinar will be made available to both UITM as well as the Mercu Buana University. I just need to check whether is Dr. Leonard is still with us? Oh, okay. I'm afraid not. Just to inform everybody, Dr. Leonard is our the person in charge of the jointly organized activities between UITM and Mercu Buana. Okay. All right. I think that's all for today. Thank you very much, Dr. Surya, for a very insightful sharing session. And thank you to all the participants who have managed to spend your little time in attending today's webinar. Thanks again for joining us today, and we will see you next time. Thank you. Alhamdulillah. Assalamualaikum.
Salam.
Waalaikumsalam. Thank you.
Thank you, Surya.